Okay, Assalamualaikum warahmatullahi wabarakatuh. So I'm going to show you the full solution of all the example in the hypothesis testing for two population mean. So we focus first for independent sample. Okay, look at example 12. Okay, a survey had been conducted to compare the rental of unfinished house in Arau and Changlun. Okay, so we have two population here, Arau and Changlun. A sample of 37 house selected from Arau produced a mean rental of 300 with standard deviation of 25. Okay, so the information here that we have is kita ada population Arau and Changlun. Okay, so for Arau we have n equals to 37, and from this sample we get the x bar equals to 300 and standard deviation sample s equals to 25. Okay, and then a sample of 42 house was selected from Changlun. So for Changlun, n equals to 42. From this sample, we get x bar equals to 295 and samples standard deviation s equals to 20. Okay, is there evidence to indicate that the rental of house in Changlun is lower than rental of houses in Arau? Okay, so dia nak test adakah Changlun less than Arau. Okay, so 5 step yang terlibat kat sini adalah, okay, before that, this one is case the population variant or population standard deviation are unknown, right? Because we only have information on the sample. But if we look here, n for both population are greater than 30. So we're going to use case number 2. So this one is case number 2. Okay, so dia kata test whether Changlun house in Changlun is lower than rental of house in Arau. So you can, awak boleh buat Changlun less than Arau, or okay, or Arau greater than Changlun, never mind. But if you want to follow the question, so our H0 and H1 is H0, H1. So let's say dia kata mu Changlun minus mu Arau equals to 0 versus mu Changlun minus mu Arau less than 0. Sebab dia kata Changlun lower than Arau, right? So number 2, our test statistic, we're going to use Z because kita punya, we does not know the population standard deviation of variance, but our sample size is large. Okay, is which is greater than 30. Okay, so Z kita adalah x bar Changlun tolak x bar Arau, 295 minus 300. Okay, so different kita kosong lah, bahagi dengan S1 square over N1 plus S2 square over N2. Okay, 20 kuasa 2, sebab tadi tu standard deviation, so dalam formula dia adalah variance, bahagi dengan 42 tambah dengan 25 kuasa 2 bahagi dengan 37 square root, don't forget. Okay, so the answer is negative 0.9728. Okay, lupa nak tulis kat sini, this one is left tail. Okay, step yang ketiga, state the critical value. Okay, so our critical value, since we want to test at alpha 0.1, so negative Z 0.1 equivalent to negative 1.2816. Okay, step yang keempat, state the decision rule. Reject H0 if test statistic less than negative 1.2816, because, okay, kalau kita lukis kat sini di sebelah kiri, so this is our rejection region with the critical value negative 1.2816. Okay, now look at our test statistic. Kita dapat negative 0.9728, which is does not falls in the rejection region. Ataupun sebab value test statistic kita is greater than negative 1.2816. So what is our decision? Fail to reject, hash not. Fail to reject, hash not, since test statistic greater than negative 1.2816. So what is the conclusion? When we fail to reject, we can say that mu Changlun equals to mu Arau. Maksudnya rental house in Changlun are equivalent to rental house in Arau. So, kalau nak buat ayat yang selengkapnya, there is no evidence to indicate that the rental of houses in Changlun is lower than rental of houses in Arau. Okay, now look into example 14. A sample of 14 cans of brand X diet soda give the mean calorie per can of 23 calories with standard deviation of 3 calories. Another sample of 16 can of brand Y diet soda gave the mean calories of 25 per can with standard deviation of 4. Test at 1% significant level whether the mean calorie per can of diet soda are different for these two brands. Assume that the calorie per can of diet soda are normally distributed for each of these two brands and that the standard deviation for the two population are not equal. Okay, so let's take a look into the information given here. So kita ada brand X and brand Y. Okay, kita ada X and Y. Okay, so untuk X dia punya N dia equals to 14, and then X bar dia equals to 23. Standard deviation S equals to 3. For Y pula kita ada N equals to 16, X bar equals to 25, and S equals to 4. Okay, and then kita nak test at 1% significant level. So this is our alpha. And then dia kata assume that the two population are not equal. For the standard deviation for these two population are not equal. Sigma 1 square not equal sigma 2 square. So this is case number 3. Okay. So first, what should we do? State the null hypothesis. Okay, H0 and H1. Step yang pertama, H0 and H1. So ada tak dia kata kat sini greater ke less than ke, tak ada kan? Dia just nak test kat sini whether mean calorie of diet soda are different of these two brand. Maksudnya ada beza ke tak? So we can make our H0 is mu X minus mu Y equals to 0, or mu X minus mu Y not equals to 0. Okay, ataupun actually you can make like this, mu X equals to mu Y. This one, mu X not equal mu Y. Okay, so this one is two-tailed test. Okay, second step. So since our sample size is less than 30 for both X and Y, so we're going to use T distribution for this example. Okay, so our T equivalent to X bar 1 minus X bar 2. So X bar yang pertama kita referring to brand X lah. So 23 minus 25 minus 0, sebab kita state kat sini different dia kosong kan, dia tak ada this one. So kalau dekat soalan ada state kan berapa different itu, baru kita gunakan nombor. Okay, divide by 3 kuasa 2 bahagi dengan 14 tambah dengan 4 kuasa 2 bahagi dengan 16 square root. So we gonna get negative 1.5604. Okay. Now, since our variance of our variance of standard deviation are not equal, you need to calculate first what is the value for DF, degree of freedom, sebab kita assume dia unequal kan. So degree of freedom formula dia S1 square over N1 plus S2 square over N2 square. Okay, 3 kuasa 2 per 14 tambah 4 kuasa 2 per 16 kuasa 2 bahagi dengan 3 kuasa 2 per 14 kuasa 2 bahagi dengan 14 tolak 1, 13 tambah dengan 4 kuasa 2 per 16 kuasa 2 per 16 tolak 1, 15. So we will get 27.4130, and we truncate into the lowest value, we get 27. Okay, now step number 3. State the critical value. So our critical value, since this one is two-tailed, so it should be plus minus T alpha over 2 alpha over 2 df. Okay, which is equivalent to plus minus T 0.05 27. So based on the T table, we get plus minus 2.771. Okay, number 4, decision rule. Reject hash not if test statistic less than negative 2.771 or test statistic greater than 2.771. Okay, so this one is, kita ada 2 rejection region at the left tail and the right tail. This one is negative 2.771, 2.771. Okay, so look at your test statistic. We get negative 1.5604, which is does not fall in the rejection region. So finally we will decide on fail to reject hash not, since negative 1.5604 is greater than negative 2.771. So what is the conclusion? If we fail to reject, means that mu x equals to mu y. Okay, now look at example 16. A random sample of 12 students majoring in maths in College of Mathematical Science has mean grade point average of 2.9 with standard deviation of 0.4. Okay, for the student majoring in computer science, a random sample of 10 students has mean grade point average of 2.7 and standard deviation 0.3. The grade point values are assumed to be normally distributed. Test the hypothesis that the mean grade point average for the two categories of student is not different. Okay, dia nak test whether ada beza tak antara these two category of student from majoring in maths and computer science. Not different. Dia tak kata pun more, dia tak kata less, dia kata not different. So H0 H1 kita adalah equal versus unequal. Okay. So the information here kita ada berkenaan first student maths and student CS. So untuk maths kita ada n equals to 12. X bar kita dapat dia punya CGPA dia 2.9 and sample standard deviation 0.4. For computer science, n equals to 10. X bar equals to 2.7. Sample standard deviation equals to 0.3. Okay. Another information that given here, dia kata assume sigma 1 square, sigma 2 square unknown but equal. So we assume population variance are equal. So kalau equal, apa yang dia adalah kes yang keempat. Okay, you have to find a post standard deviation lah. Okay, so now what is the hash knot and H1? Step yang pertama, state your hash knot and H1. Okay, so mu max minus mu CS equals to 0 versus mu max minus mu CS not equal 0. Okay, so this one is to tail. Step yang kedua, our test statistic, we're gonna use T because sample size is small. Kita tak tahu population variance. Okay, so that's why kita akan guna T. So T equal X bar 1 tolak X bar 2 minus D. X bar 1 kita adalah 2.9 tolak 2.7 minus 0 over. Okay, SP kita tak calculate lagi ya. Okay, so 1 tak apa. 1 over 12 plus 1 over 10. Okay, calculate dulu SP. SP kita N1 minus 1, 12 tolak 1, S1 square, 0.4 kuasa 2, tambah 10 tolak 1, darab dengan 0.3 kuasa 2, bahagi dengan 12 tambah 10 tolak 2. Jangan lupa square root. So finally we get this value is 0.3585. Okay, so kat sini formula dia SP kan, kat sini 0.3585. Okay, step yang ketiga, critical value. So since this one is two-tail test, so our critical value is plus minus T alpha over 2, N was plus N2 minus 2, 12 plus 10 minus 2. So kita akan dapat plus minus T berapa alpha kita 0.05. So this one is 0.025. 12 tambah 10 tolak 2, 20. Okay. So the value is equivalent plus minus 2.086. Okay, so dia punya step yang keempat, kita nak buat kita punya division rule. So the division rule, kalau kita lukis kita punya so this one is negative 2.086. This one 2.086. So this is our rejection region. So division rule kita akan reject hash knot if test statistic less than negative 2.086 or test statistic greater than 2.086. Okay, now kita tengok kita punya test statistik kita sorry, lupa nak calculate tadi berapa? 1.4353, betul tak? Nanti you all check ya. 1.4353. Okay, 1.4353 tak masuk pun dekat dalam rejection region. So our decision fail to reject hash knot since test statistic less than 2.086. Okay, so fail to reject means that mean untuk math students are equivalent to mean computer science student. Okay, awak buat ayat yang betul lah. Okay, ayat yang lengkap. There is no significant evidence to indicate that the mean grade point average for the two category of student is not different. Okay, let's continue example 17. A new chemical process is developed for the manufacture of nickel-cadmium batteries. The company believes that this new process will increase the mean lifetime of a battery by 5 hours as compared to that of batteries produced by the old process. Okay, so kita ada dua population kat sini, old process and new process. Okay, assuming all battery lifetime to be normally distributed, test at 5% significant level whether there is a difference in the mean of the two process. So, kita just nak tahu ada different ke tak between the two process. And assuming the variance are equal. Okay, so kat sini clearly dia dah bagi tahu variance are equal. So, this one is case number 4. Okay, sorry. Kita assume variance are equal. Okay, and then kita tengok pula N dia kecil, betul tak? N dia kecil, which is less than 30. So, this one automatically we're gonna use T. Okay, now let's state the H naught and H1. So, H naught dia adalah mu O minus mu nu equals to 0. Versus mu O minus mu nu not equal 0. So this one is two-tailed test. Okay, step yang kedua, kita kena calculate dulu full standard deviation sebab dia tak bagi kan, sebab dan kita assume dia variance are equal. So 13 minus 1 S square, 9 tambah 1 kuasa 2 tambah 15 tolak 1, 8.3 kuasa 2 bahagi dengan 13 tambah 15 tolak 2. Okay, so the answer is 8.6784. Okay, now baru kita boleh calculate dia punya test statistic. Test statistic. So our test statistic is, kita akan guna T, X bar 1 minus X bar 2, 105.2 minus 112.4 minus 0 over SP 8.6784 square root 1 over 13 plus 1 over 15. And finally we get negative 2.1894. Step yang ketiga, we want to decide on the critical value. Since this one is two-tail, don't forget plus minus T alpha over 2. So alpha kita is 0.05 divided by 2, 0.025. Degree of freedom dia 13 tambah 15 tolak 2, 26. So kita dapat plus minus 2.056. Okay, step yang keempat, state the decision rule. Okay, so kalau nak buat decision rule, saya suka lukis. Okay, now we have two tail, right tail and left tail. This one is negative 2.056. This one is 2.056. We will reject H naught if test statistic less than negative 2.056. Reject H naught if test statistic less than negative 2.056 or test statistic greater than 2.056 for the right tail. Sebab dia ada two tail, so kita kena tengok kedua-dua, both side. Okay, now barulah kita nak decide. Okay, so tengok dulu kita punya test statistic value kita negative 2.1894, which is less than negative 2.056 and falls in the rejection region. So our decision is reject H naught since negative 2.1894 ataupun test statistik kita less than negative 2.056. Kita reject means that the average of all process are not equal the average of new process. Okay, so kalau awak nak buat ayat yang lengkap lagi, boleh buat cara there is a difference in the there is a difference in the mean of the two process. Sebab kita reject hash not kan. So kita boleh kata mu old process does not equal mu new process.